Hello? Oh, we're live. Okay, great. Hi, everybody. Welcome. Thank you for coming to Virtualize Active Directory the right way. We understand that we are separating you from the hall crawl, so we appreciate your attention and everybody coming here. My name is Matt Leibowitz. I'm the global lead for cloud and virtualization within Dell EMC Services. You have your mic on?
My name is Deji Akamalafe. Well, Deji. Forget the other one. I'm the practice lead for Microsoft Application Virtualization at VMware. So everything that has to do anything with Microsoft application on vSphere, that's what I do. Thank you very much for being here.
Yeah, so quick show of hands before we get started. How many people in this room are already virtualizing Active Directory?
Oh.
Whoa. All right, thanks for coming. Fill out your surveys. Appreciate Wow, no, that's great. Well, I think our goal here is to make sure you know all the tips and tricks and the best practices for virtualizing it, but great to hear that you're already doing it. As usual, you've probably seen this 100 times. Disclaimer, we're probably not going to be talking about anything futures related, but in case we do, we're covered here. And here's the agenda that we're going to cover that we're not going to show you because we're going to get right into it. Go ahead, Deji.
When we started this, what, 10 years ago or 15?
Something like that. I had hair.
We quickly discovered that the people in the room are smarter than us when it comes to Active Directory. So we've confined ourselves to just letting you know how to do it on vSphere, how to virtualize it. This is not an AD class. Okay. However, we can't really show you anything, and we can't really tell you anything useful if we don't try and relate some of the requirements or the core considerations for Active Directory, and just at a high level, letting them know how they relate to what we are about to show you. This, by the way, is the Living on the Edge session. We are going to be doing real life demo, so if you have chicken, please, we would like to sacrifice some to the gods. AD is a multi-master. It's a multi-master replication system. You have domain controllers that share the same database, and they replicate among each other. Every domain controller is identical. Every domain controller is disposable. We used to have some trick questions back in the days when AD came up, and we ask you, which is the most important domain controller in your infrastructure? And we used to get things like, oh, it's the PDC emulator, you saw the schema, no, it's the infrastructure master. Every domain controller is disposable and they are equal. However, the RODC, of course, is a special case, and we have the schema update, which is also a little bit special. We are not going to talk about that. When you create objects or make changes in AD, there are selective partner replication. If you have thousands of DCs in your environment, they choose partners to replicate with. And how they replicate with them depends on the topology, your Active Directory site and services, which we are not going to get into. The objective is that when a change happens or a write operation or delete operation happens on the domain controller, that change has to get to another domain controller in the environment. Hopefully, you have more than one in your infrastructure. How it gets there is a bit too deep for us here. It must get there is what we are going to focus on. Replication must converge eventually. They must converge on time, preferably, but they should converge. There are additional complexity when you have the multi-domain infrastructure and you have the IAM not on the global catalog. But again, we are not going into that details. There are some useful tools for you to troubleshoot your AD replication infrastructure or topology, and we are going to show just one of it very quickly down the road. Now, when we say change that originates from one DC has to replicate to the other DC, how do they do that? We are going to see that real quickly. Overview of AD replication. The directory services itself as a GUID, a DSA GUID. Please, I'm not teaching you anything you don't know. The GUID is unique to a DC, and it's persistent over the life of a DC. When a DC gets a GUID, that GUID remains with that domain controller for as long as the domain controller continues to live. The GUID is used in update sequence number to track originating changes. Please bear with us and stay with us because we're going to show you how we can screw that up. Then you have the invocation ID. The invocation ID is used by the DSA to identify a deceased copy of the AD database date. Now, you take the invocation ID, which can change over time, you marry that with the GUID, and then you have the update sequence number. Every change to an object in AD gets an update sequence number. Okay? The update sequence number is used to track what is replicable. What do I need to send to another domain controller? What have I received from one or the other domain controllers? Very high level. It increases every time there is a change. So please hold on to that. USN increases every time there's a write or delete or any operation. And it's globally unique in a forest. If it's not, we have an issue, and we'll show you an issue. So now you put the USN plus the invocation ID, and you have transactions that a DC says, I need to replicate to my replication partner. Now, we have other considerations like timestamp. Of course, how do we know that this change is the latest? If those changes happen, if the change happens simultaneously on more than one domain controller, how do we arbitrate that? We use things like stamps. Okay, the stamp will be the version of the object, the originating time on that DC, and the originating DSA. We now have a uniqueness that we can replicate from one domain controller to the other. Again, very high level. I know you know this better than we do, even though we pretend to know it more. Let's ask the question, why would you virtualize Active Directory?
Sounds good. All right, great. Thanks, Deji. Let's talk about why, and kind of why we're here. Well, number one, virtualization is clearly mainstream. I don't think anyone in this room is saying, this is the year, we're going to do it. Most organizations already have virtualization first policies. It's a standard. There's no black magic. There's nothing scary about it anymore. Active Directory virtualization is fully supported by both VMware and Microsoft. And I think Microsoft deserves a lot of credit here for having policies that are friendly to virtualization. All roles on the domain controller, all the FSMO roles are fully supported when virtualized. There was a time in the past where people said, well, I can't virtualize my PDC emulator. We're going to show you why that's not a problem anymore, but support was never an issue, always been supported. The characteristics of domain controllers are very friendly to virtualization. When you think of things that are hard to virtualize, they're usually very large, they've got lots of resources, and they're usually a database server that lots of different systems are hitting. The architecture of AD, it's multi-master, which means they're all the same. One can go down, the other one stay up, and it's still okay. Makes it very easy to virtualize. The fact that it has low I/O requirements, low CPU and memory requirements definitely helps as well. It's a pretty easy candidate for virtualization. Now, DCs are also interchangeable, like we've mentioned. It's easy to deploy another one, promote it to a domain controller, transfer roles, and again, now you have another domain controller. You can also deploy them very quickly because they're in virtual machines. I can deploy from templates, just like I do all my other workloads. Physical domain controllers today, on the physical hardware, like for Dell EMC, our customers that are buying big systems that have 36 cores and a terabyte of RAM each, Windows can scale to that level, but a domain controller is not going to use all of that. So you're clearly wasting money if you virtualize on a physical hardware, especially that large. Now, we're going to talk a little bit about some of the objections that Deji and I have heard over the years to virtualizing domain controllers. Well, the first is this fear of the stolen VMDK, and that is someone accesses either the ESXi host, the storage platform, or maybe a backup tape. And now they have my VMDK for my domain controller, and now they have access to my domain database, and they can do whatever they want with it. And while there is a small risk to that, we have a solution for that we're going to cover in a few slides and we're going to show in a live demo. Just cross your fingers for that one. Privilege escalation. This one kind of bugs me because this has been something we've been dealing with for a very long time. A lot of people still think if you need to be a vCenter admin, you also have to be a domain admin. And all domain admins should be vCenter admins. Don't do that. There's no reason to do that. You know, there was reasons why that happened in the past, but there's never been a full reason to do that. You can use role-based access control to control access. You absolutely don't need to do that. This one we've heard many, many times. Well, I have to keep my certain, you know, FSMO role physical. It's usually the PDC emulator. People say, I need to keep that physical. There's no question you don't have to do that. There's no technical reason. There's no support reason. You can transfer FSMO roles very easily between servers live while they're up and running. And you can also seize roles. And in fact, the last time Dej and I were doing this presentation, the lab crashed so bad the night before that we had to seize FSMO roles. I know, So anyone have a chicken? So it's really not a big deal. You can easily transfer or seize the roles. There's no reason not to virtualize. Does it deviate from your standard build process or your standards? This might have been true several years ago, but these days, again, customers have a virtualization first policy. There's no reason to deviate. That would actually be the deviation, to put it physical. So that's less of a problem. Now, timekeeping in virtual machines is hard. We completely agree with that. And actually, not only is it hard, it's important. And it's doubly important for domain controllers who are very insensitive to clock drift and issues with time. So here's what we've done in the past. We said, if you think back several years ago, we used to say, disable time synchronization in the guest. So disable Windows time on all your virtual machines, sync time with, ooh, it's a green, this is an upgrade. Synchronize with the ESXi host, make the ESXi host talk to an authoritative source, and then you don't use time sync in the guest. And then we said, they fell for it. We changed that and said, that doesn't work well. Disable this feature, don't synchronize time with the host, use the standard Windows domain hierarchy. Domain servers and members sync to domain controllers sync to the PDC emulator syncs to a Stratum one-time source. We say do that, keep it separate from ESXi, and everything will be fine. The challenge with that is that that also unfortunately doesn't work. Because even when you do that, even when you separate ESXi time sync from the guest, this still happens. When you perform certain operations, time sync still occurs within VMware tools. And those operations are, a bunch of them are listed here, but the big ones are migrate a virtual machine and reboot a virtual machine. So we're talking about Windows here, right? So occasionally those servers need to be rebooted for patching and everything else. And I suspect many of you are using DRS to migrate workloads. So that will kick off a time sync with the guest every single time. Now, what we're going to do here is we're going to show you what happens when you do that on a host that has bad time. So what you see here, here's our bad host. You can see that's set to December 17th, 2017, which is a day I will probably be taking off from work, and I suspect many of you will as well. That's the next Star Wars movie. But this is wrong. This is in the future. Not only is the time wrong, the time service on the ESXi host is also disabled. So what we're going to do now is we're going to log into vCenter here. We're going to show you what happens when we actually move that virtual machine that has proper time. You can see the time is incorrect. Pay no attention. This must have been when we did the demo in.
Yeah, right.
So what we'll do is we'll just fix it and we'll show you again. We tested this about 30 times before we did it. So what we're going to do is we'll fix the time, and then we'll do a vMotion, and we'll kick it off from a good host to a bad host. And what will happen, if all goes according to plan, what you'll see is this will actually change on the fly without anybody doing anything. So if you can just imagine for a second, you've got DRS in fully automated mode, you've got virtual machines moving all over the place based on load in your environment, and you've got a host that has bad time. So you're going to see what can happen here. I don't think we need to worry so much about the time. Let's just change the date. All right, perfect. Okay, so is that today? That's good enough. Okay, so go ahead.
There are two VMs here, one with good time and one with a bad time. I'm going to bring up the one with, both of them will be having a good time right now, and they'll be happy. And we are going to vMotion both of them. So I'll kick off the vMotion operation.
Yeah, well, you'll see for all these demos, we script them because this lab is big and it's too hard to go through the vSphere client to show you. But as you can see down here, there's no magic. We're just kicking off a vMotion. All right, so why don't we go back and so you can see already, you can see without even looking. Anytime you're ready, there you go. That's the old one. So that's the good one.
Both of these VMs are now on the bad host.
Yep.
One of them inherited the the bad clock, the bad time on the host, and the other one is not impacted.
Yeah.
How did we do that?
So we're going to show you that in just a second.
This is one of the things that happen in your environment, and any AD administrator will tell you this is bad. Why did we go through the USN and replication and time sync and timestamp and everything? Because a deviation of about maybe 5 minutes or more is problematic for Kerberos. And this is one of the reasons why people keep some of their domain controllers on physical servers to avoid this situation. And there are ways to fix that.
Yeah, so let's start. It starts, obviously with the host. Make sure your ESXi host is syncing to a known good time source. Now, whether that's an external source on the internet. We've had some customers that have GPS systems on their roof and they sync to that. Whatever it is, as long as it's trusted, make sure ESXi is syncing to that. Make sure the clock on obviously the hardware clock on the host is set correctly. Disable DRS for the PDC emulator and use host guest affinity. The only reason we're recommending that is because that role is particularly important for time sync, it's good to know where it is. It doesn't necessarily have to stay on the exact same server, but it's good to always know where it is. But to actually completely disable this feature, there's a bunch of settings that you can enable within the VM's advanced configuration, essentially the VMX file, that you can set all these so that no matter what you do, like you saw in the demo, one of them worked, one of them didn't. This will not sync time within the guest. Now, you can set this either manually, you can set this programmatically if you're really good with PowerShell and PowerCLI, or VMware's created a vRealize Orchestrator workflow package that you can actually do this across all your guests all at once. Again, keep in mind, this applies to everything, not just domain controllers. It's just domain controllers are less sensitive to time drift. They definitely do not like it. So this is a handy vRealize Orchestrator workflow package to have with you. Now, one thing is slightly different with Windows Server 2016. The polling frequency and the frequency with which it updates the clock has increased, which is a good thing. You're going to try to stay more in sync. The sort of bad thing is that it introduces additional CPU load onto your domain controllers, and really all servers, but domain controllers primarily important. Now, Microsoft has an exhaustive knowledge base article on this, and I'll only spoil it a little bit for you. In the vast majority of cases, this doesn't matter. It's not going to be enough to move the needle. But Microsoft says if CPU utilization on your Windows Server 2016 domain controllers is high, you could have less accurate updates and more clock drift. And Microsoft's definition of high is 40%. So if you have a domain controller that's 40% utilized or higher, and you haven't yet upgraded to Windows Server 2016, it might be a good time to look at the utilization on that, figure out why it's high, and potentially address it. Because if it's high, if it's 40% or higher, and you go to 2016, it's only going to get higher, and your clock frequency is not going to be updated as much. All right, let's talk about virtual machine security and encryption. You heard we were going to mention that. In Windows Server 2016, there's quite a bit that's new, and there's new stuff in Active Directory, but there's actually not a ton of new things that are specific to virtualizing Active Directory. But we are going to touch on some security features that are useful for domain controllers. The first is they introduced something called the shielded virtual machine, which lets Hyper-V encrypt a virtual machine so that it can't be read if the VMDK or their VHD is taken. VMware vSphere also supports that, and we're going to show that in just a second. We're going to show that with a live demo. The other one is something called Virtualization-Based Security, another Microsoft acronym called VBS. And really all that does is it uses the hypervisor to protect the kernel and the operating system from executing malicious code that it doesn't trust, things like malware. It is not supported in the current version of vSphere. However, in a future version of vSphere, it will be supported. You can learn quite a bit more about this in the next in this knowledge base article from Microsoft. We couldn't show you a demo, so we're just showing you a picture because we want to prove that it does work. This, you'll have to trust us because there's the virtual machine up there. We got this to work in a future version of vSphere, but unfortunately we weren't able to show it to you here. But just know that in the next release, this will most likely be supported. Now, sorry, go ahead. Were you going to?
Go ahead.
So what we want to do is talk a little bit about how we address the stolen VMDK, the virtual machine encryption. So vSphere 6.5 now supports encryption. It secures and encrypts the entire the VMDK so that all the data in there is inaccessible and unreadable unless you're on a trusted system. The VM has the decryption key, and vCenter really, it just acts as the broker. You can see here, it doesn't have its own KMS, and in fact, it uses industry standard KMS. You don't have to deploy anything special for this if you're already using KMS. You don't need any special hardware on your server. However, if you have AES-NI, the new instruction set from Intel, performance will be better, but it is not required. Now, I'm not going to go through all of this. There's quite a bit of data here. There are sessions on virtual machine encryption that you can go to. They know far more about this than I do. What I want to cover is what's in red here. If the ESXi host is power cycled or it's not available, then vCenter is going to say, give me the encryption key here. It's going to request a new one from for the host. If a virtual machine that's been encrypted has been unregistered from vCenter, and then you try to re-register it in a different vCenter, it's going to say, give me a new key. If it can't get the key, because that vCenter is not connected to KMS, which means it's not the right domain vCenter, the VM won't even be able to be powered on, and the VMDK is encrypted so nobody can read the data on the disk. So what we're going to do right now is hop over to Deji's machine again and show you what that looks like.
The previous 3 slides specifically address the stolen VMDK conundrum. What if somebody gets that VMDK, they have access to the DID, they have access to my AD infrastructure. What we are going to show you is a whole VM encryption feature in 6.5, which addresses that concern. Again, as Matt mentioned, we do not insert ourselves into that encryption facility. You provide your own VMDK. We do not do anything. We just tie into whatever VMDK you have in your environment. In this demo, how we taking a VM that's been encrypted, whose disks have been encrypted, like here.
See that right here?
And we are going to try and steal it. So I'll power it off, and I'll take it to my dungeon, and I will try to bring it up and read your secrets. Okay?
No, you don't want to be in Deji's dungeon. Okay, so what we're going to do, we're going to, again, we have a bunch of scripts that do this that are going to try to copy the VM, unregister it, and register it on another host. Right now, remember I said before, when we register that VM on a host that is not part of the encryption, it doesn't talk to the same KMS server, we're not going to be able to power the thing up. So
because we can steal it while it's live, I turned it off, removed it, and now I'm going to try and register it on a host that doesn't exist in this infrastructure. So let's see. Pray for me.
You can do it. I believe in you. All right, so again, go ahead. There you go. This is what it's like to type your password in front of 500 people. So.
All right, stolen VM, and there is that VM. And that VM is now invalid because it stepped out of that encrypted environment. Do we see it?
Yep. Yeah, right there.
Now your DID is safe.
Yeah.
I'd like to say if somebody is able to actually steal your VMDK, and go replace somewhere else. We have more than technological issues, but we have the solution for you.
Right. So not only can you not power it on, but you can't read the data that's in there anyway because it's encrypted. All right, great job. Thanks, Deji. All right, so now let's move over to some best practices that we'll try to get through quickly. We've got a couple more demos we want to show you. Best practices for virtualizing a domain controller. If you have multiple data centers, this makes obvious sense. Deploy domain controllers in all of those data centers. Distribute the FSMO roles across multiple virtual machine or domain controllers. In case you're not aware and you've never looked, the first DC, the first domain controller in a domain, gets all the roles. If you've never actually gone in and separated them, they might still be living on that same server. So follow Microsoft's best practices. They have a great document here. It applies to physical and virtual. So separate your FSMO roles. Use effective role-based access control. I said this once already. I have a feeling I'm going to say it one more time. Don't give domain admins rights to your vCenter, and vCenter admins don't need to be domain admins. It only makes sense in really, really small environments where you're the same person. Otherwise, if you've got a large environment, there is no reason to do that. Role-based access control is the way to go. Now, P2V or not to P2V. Let's say I've got a physical domain controller and I want to virtualize it. Should I P2V it? There's really one reason why you would do that, and it's if you truly hate yourself. That's the only reason. Really, the reason is if there's a piece of software on there or something that you just can't get rid of, there is a knowledge base article on how to do it, but my recommendation is don't. Deploy a new server, promote it to domain controller, transfer FSMA roles, and decommission the physical. It is so much easier. And then use affinity and anti-affinity rules to keep domain controllers separated, so if one host goes down, you don't lose everything, and you always know where certain domain controllers are. Now, we'll talk quickly about how we size these. The one thing I'll say to take away from this is don't assume just because it's a domain controller, it's not doing anything, and so it doesn't need a lot of resources. When it comes to CPU, Microsoft's guidance is simple. Up to 10,000 users, one virtual CPU is okay. And actually, with new modern CPU cores, one is probably okay for even more than that. If you have more than 10,000, start with 2 and scale up if you need to, if you don't have access to another domain controller where you can monitor it. For memory, domain controllers, the way I like to think of them is they're just like database servers. And if you're familiar with database servers, they cache the database in memory so that reads come from RAM instead of disk, which improves performance. Domain controllers can do the exact same thing. Now, if you're not sure if the VM has enough RAM, Microsoft provides this counter, this perfmon counter, where you can look and see what the usage is. How much am I hitting the cache? If it's low, there's probably a good reason why, and it probably doesn't have enough RAM. Network and storage are easy. VMXNet3 is pretty standard for most virtual machines. Storage, it really only needs, it doesn't need high performance storage, but it does need enough storage to store the AD database. It needs the operating system and any additional files, like software you install in there, backup agents, things like that. And then it needs room to grow. Don't outgrow the storage space on your domain controller. All right. Now we're going to talk a little about DNS. Deji's favorite issue.
No, it's not. This is not my number. This has been the number I've been getting from Microsoft for a very long time. 75% of AD-related issues can be traced back to DNS. AD depends on effective DNS functionality. Clients and DC need to be able to locate each other. Your locator services, your records, everything needs to get in sync. The initial replication of a domain controller goes this way. This domain controller comes up. The first thing it does is it looks for somebody to replicate with. That is standard. If it's able to find a person to replicate with, it says all is good, and now I can advertise myself as a domain controller. It starts servicing client requests. Now, the DC must perform this initial synchronization check before it can begin to advertise itself as a domain controller. The DC cannot synchronize with somebody if it cannot resolve that other DC's name. It would be like you going to China and saying, or coming to the US and saying, I'm looking for Smith. Smith exists everywhere. You can disable these checks and have your domain controller not look for Smith if you want. Microsoft supports this, but they advise against it. A registry key will help you disable that initial check. But then how would you know if all your other domain controllers are not able to talk to each other? That is a good reason to not use this Swiss Army knife. Where are we going? Let's describe it in visual form. This is your domain controller. DC1 starts up. What does it do first? It initializes the network stack. What's my IP? It says, what's my DNS IP? Can you see that? What's my IP? What's my DNS IP? This domain controller just points to itself as DNS server, its own DNS server, its own name resolver. Then it says, okay, my DNS service is at 10.10.10, okay, which is where I am. So now I need to sync with DC2. It knows DC2 by name. It doesn't ask for DC2 by IP address or MAC address or any other thing. It says DC2.mydomain.local, please, I need to talk to you because I'm required to sync. Oh, wait, I need to resolve the name. All right, DNS service, could you please start so I can resolve this name? And DNS service goes back and says, oh, wait, I'm not allowed to start until you've been able to sync with another domain controller. Excuse me? You following? All right. That's what happens. This is why your domain controller, pointing to itself in your enterprise, is unable to start servicing requests from your client, and eventually it becomes an island. And it won't be able to replicate because it can't see anybody, which is why we always recommend when you configure your DNS in your environment, please make sure your domain controller points to at least another domain controller for primary name resolution, and then to itself, maybe as a fallback.
Okay, so a couple historical problems. I'm not going to go through the first ones because they're relatively old and they're solved, but I have links on here. The biggest one is what Deji talked about in the first few slides, and that is how domain controllers keep track of transactions and how they know who's right and who's authoritative. And as you heard him say, it tracks transactions with every other member using unique sequence numbers, or USNs, and then invocation IDs. You can see that right here. Now, a domain controller that's been previously reverted to an old state, either through a snapshot or a backup, is going to try to reuse those USNs because it doesn't know that they were used. It's sort of like a Back to the Future where now it's back in a state where it doesn't realize those transactions have been used. So you get into a state called USN rollback. The domain controller thinks everything's okay, so it tries to replicate. The other domain controllers say, no, I know you're not okay, so I'm not going to accept it. And it essentially gets orphaned onto its own island here. So what we're going to do quickly is show you what this looks like graphically. We were going to show it in a demo, but just not enough time. All right, so here's sort of known good state. I've got invocation ID A here and USN 100, highest committed transaction. DC1, DC2. They both know the same USN. Let's say I create 10 users, so I've created 10 transactions that I need to replicate. USN has increased. It's going to replicate it over to DC02. DC02 is going to say, oh, I accept this. These are good transactions. I'm going to update mine as well. So now we're both at 110. Now I'm going to be a sneaky administrator, and I'm going to take a snapshot of my virtual machine. And I'm going to say, OK, snapshot's created. 10 more users are created. Again, USN has been increased. Now we're up to 120. I'm replicating that over. DC02 says, that's still fine. I understand that. These USNs have not been reused. I'm going to commit those transactions. Now we're up to 120. So I'm at 120, but now I'm going to revert back, or I'm going to revert back to the old snapshot. So now I'm back to, according to this DC's perspective, I'm back to USN 110. So here we are. This is like the point in the horror movie where they say, the call's coming from inside the house. Everything is working right now until we try to do something. I'm going to create 10 more users, but I'm going to try to reuse 111 through 120 because I don't know they were used. I'm going to replicate them. DC02 is going to say, nope, I don't accept that, and this happens. That domain controller is effectively orphaned. It thinks it can still service requests, but it really can't, and it can't replicate anything.
This is the reason we went through the initial 101, vector, UTD, USN, and all that. When you combine this together, that's how domain controllers verify transactions that have been replicated to them and what has not been replicated. If you then roll your domain controllers back by snapshot or by other things, restore from tape, and that domain controller tries to reuse a USN that's been used before and tries to replicate that to another domain controller, the safety check back in the days, I'm talking 2018 on, is this domain controller is going to say, no, I already got 120 from you. I already got that USN from you. I'm not going to accept this transaction. Obviously, something has happened to you, so now I'm actually not going to talk to you anymore. Anybody gone through a USN rollback issue in their enterprise before? Very painful to recover from. You will have to call Microsoft, and if you're lucky, it will take you maybe a week to recover. This is one of the biggest reasons why people actually don't virtualize domain controllers. Why? Because we make it very easy for you to take snapshots and for you to replace snapshots. We make it very easy for you to say, oops, I deleted something yesterday, let me go get the old snapshot. When you restore that, you are bringing back already used USN. And then when you populate that, you are going to either try to pollute your forest, or you're going to have disconnected DCs that don't talk to each other anymore. In that situation, what happens, somebody whose password changed around the time you took the snapshot and then restored. Now you got old password back. They can log into this domain controller that you've restored because that was the old password. However, they try to use the same credential on another domain controller that has the current password. You have a situation, right? What did Microsoft do? Tell me.
So they've introduced some new features to help this. In Windows Server, starting in Windows Server 2012 and supported through 2016, they have something they call the VM generation ID, which is essentially a value that the hypervisor can pass through to the virtual machine through a counter, through a driver directly in the guest. And that driver is not part of VMware tools, it's part of Windows. So that allows it to work with vSphere and actually other hypervisors as well. In order for that to be exposed, you need to be at least at vSphere 5 Update 2. Now, I realize we're at 6.5. I expect most of you are in this ballpark, but just want to make sure you're clear. It needs to be that version. It's exposed as a property inside the VMX file. And actually, if you edit a VMX file of a Windows Server 2012 or 2016 guest, you will see this, whether it's a domain controller or not. Now, if you install 2012 or 2016 in a VM, but do not properly set the operating system as Windows Server 2012 or 2016, this will not be generated. And all the stuff we're about to talk about will not work. So be aware of that. Now, it's tracked as an attribute in Active Directory, but it's stored only in the local copy of that domain controller's database. So the local copy of the database is the only place that that value is stored for each domain controller. And you'll see why that's important in a second. It doesn't replicate. We're actually going to show a demo of this shortly. If there's a change in that generation ID for any number of reasons, like reverting a snapshot, restoring a backup, two things are going to kick off. It's going to kick off the safety mechanism. That's how it protects virtual machines and domain controllers from USN rollback. Now, it can do two things. It can do safety, or it can do cloning. I'm just going to quickly show you what this looks like. Go ahead.
Let me stage this. Switch, please.
You want to show the demo first, or you want to show this?
No, I want to kick off the demo, the time.
Okay.
So he's going to go through this, but I want to show you quickly what we are going to demo in the interest of time. So we have this domain here. We keep it simple, two domain controllers, DC1 and DC2. What I'm going to do is I'm going to take a snapshot of one of the domain controllers. Just so you're aware, please stay with us where it's in the interest of time. We have users here that are created in the domain. What we're going to do is we're going to take snapshot, and then we're going to delete the users, and we're going to restore the snapshot. And I'll be doing that in the background, and you can.
Okay, so while he's doing that, I'm just going to show you what this looks like graphically. So here we go. Similar to before, I've got a vSphere host, the DC01, DC02, generation ID 001. We made this simple. If you actually look at this, it's a crazy number, but 001. I've got starting USN 101, invocation ID, USN, or the VM generation ID. So everything is set right. So here's what I'm going to do. I'm going to create a snapshot. Same just like I did before. Then I'm going to create user 1. So DC01 is going to replicate that to DC02. DC02 is going to say, I accept that, that's fine. Now I'm going to revert the snapshot back. So now I'm back to the state where it didn't realize it did that transaction. So it recognized that I reverted the snapshot, so it changed the generation ID. It's going to kick off the driver inside the guest to update the local copy of the generation ID on that domain controller. So it's going to change the generation ID, it's going to change the invocation ID. So now we're back. Now I want to create user 2. It's going to replicate that over. DC02 is going to say, I recognize, I've seen this transaction before, but I know you have a new invocation ID, and I know that generation ID kicked in for safety. So I'm going to accept that transaction. Not only am I going to do that, I'm going to give you back the one you missed before we did the snapshot. Now in Deji's, in the example we did before, this didn't work. The domain controller became orphaned, and it didn't work. In my example, everything is awesome. Everything is cool. First of all, I can't believe that actually worked. I feel like I've reached peak PowerPoint. Okay, so let's switch back. Let's show you what that actually looks like.
Okay, so I've just taken a snapshot of the domain controllers while you weren't looking. This is DC2. It's been a snapshot. It has the same information as DC1. We are going to go ahead and we are going to delete all of these users. How do you delete?
This is why you don't make Deji a domain admin.
Please remember when we took the snapshots, there were users in there. Okay. In 2012 and above, when we bring back the domain controller to what it was before, it will see the date. But then it will be by design required to discard everything it knows about the domain, including, again, its USN. It's going to forget itself. It's no longer a domain controller. And we are going to, Windows is going to take the opportunity to rectify the VM and say, you are, where, what did he say? Okay.
Okay, so we'll revert back to the snapshot we just took. You can see he's working off
to create users.
2016 Windows Server 2016 server. Yeah, so we've already the users have been deleted. They were there. Like he said, what in the old scenario, what would happen is if you revert that snapshot, those users should come back because the domain controller doesn't know. It thinks it should restore them. In this case, it should say, hey, my generation ID changed. Give me a new invocation ID, check with the other domain controllers, and tell me what I've missed.
Why don't we make this a little bit interesting, and we're going to
Sure, why not?
We're going to create a folder here, just so you know we're not tricking anything. New.
It is Vegas after all, right?
Yeah, show of hand, slate of hand, and things like that. Okay, so here, we're going to actually make it more. We're going to create new users as well, right? So then we're going to give this new user to the domain controller that we just reverted. Please bear with me.
Sure. Yeah, I mean, we didn't practice this, but what could go wrong?
Oh, come on. I'm just going to create you. Is it okay?
Yeah, go ahead. So you're just going to manually create the user, or you're going to kick off the script? There you go. He's got a script just for me. I don't know how I feel about that. Okay, so if we go back, we should see that I now exist. If you go back to that domain controller, 80 users and computers on that server 2016, refresh that view, I should now exist. Sure we're on the right one? This is why we only do the stuff we practiced. There we go. Who said that?
Okay. Thank you, sir.
Thank you, sir.
No surprise for you. Okay. Now we go and we restore the snapshot that we took prior. We do?
Yeah.
Okay.
Sure. This is your show now. I'm just going to slowly back away. All right, so here we go. Type in the password, and it's going to go back to the state before we created the me and deleted everybody else. And I don't know if you have the vSphere client up to show them, although I'm sure they trust us. There it is.
It's reverting snapshot.
Yeah, everyone see that? Reverted the snapshot.
And if you look very closely, this will blip a little bit. And what it's supposed to do, what you saw before was those users who deleted came back and tried to replicate, and they weren't talking anymore. So this VM has been rolled back. You saw the blip that just happened? You don't trust me? Yeah, they were looking at me like, he's lying. So we're going to go to Event Viewer, and we're going to show that this domain controller actually lost its identity, and now it's a new domain controller entirely. The invocation ID, the invocation attribute for the directory was discarded. So let's do this.
That is fancy. That is too much.
Okay.
I don't know if you guys can see that down there. You can see it actually says, hey, the invocation ID changed.
Yeah, this.
Yeah, right there.
This domain controller comes up. It says, I'm a domain controller, and I have changes that I need to send to you. And VM generation ID says, you're not. You've been gone. You've been reverted. Your VM generation ID has changed. We are going to now make you a new domain controller. We don't change the name, we don't change anything. We just say, forget everything you knew about this domain, about this forest. You're not replicating anything out here. Here, take what we had while you were gone. So, do you or do you not virtualize your domain controllers? Do you or do you keep one specific domain controller on physical because of rollback and because of restore? There is really no technological or technical reason for you to do that today.
Okay. All right. Well, in the interest of time, we're going to move on quickly. So was there something else you wanted to show? All right, let's go. So just because you can do this with snapshots, does it really mean you should? Well, there's a couple reasons why you might. The first is backup software obviously creates image level backups, and if you need to restore the whole domain controller, this will kick in and protect it. The other is the old reason why everyone uses snapshots, and that's, let's say I need to install a piece of software on my domain controller. Backup agent, security, antivirus, it's something. I can take a snapshot, I can install the software, and if it breaks something, I can revert it without having USN rollback, without breaking my domain database. Now, just because you can do that, obviously, snapshots are not backups. I think everyone in this room knows that. Please tell me you do. It is much, 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 much easier to either, one, just restore from a domain controller the thing that's not there anymore, like an OU or a user or a group, rather than the whole server. But if you do have a server that's completely failed, deploy a new server, promote it, transfer the roles, and decommission the old one. It's so much easier than trying to restore this thing from backup. It's unlikely you're going to use this much in day-to-day life, but if you're using 2012 or 2016, you're going to be happy to know that it's there. Now, the other thing we're going to do is domain controller cloning. This one takes a little time. I don't know if we're going to be able to get through the whole thing, but we're going to give it a shot.
Let's describe that first.
I will describe it first. Sure, why not? All right, so domain controller cloning lets you actually clone using regular vSphere cloning a domain controller, and it does it safely and it does it quickly. Now, you have a process that you follow that we're going to hopefully be able to demo for you. First, you need to add the DC to a group in Active Directory called the Clonable Domain Controllers Active Directory group. Then there's a process that checks for software on the domain controller that doesn't support cloning. VMware Tools does, not everything else does. So it checks for that. Then you create what's called the DC clone config file, which is effectively the configuration for the cloned server. So, you know, your IP address and things like that, the name. Shut down the source domain controller, clone it using regular vSphere.
Please pay attention to that last bullet. There's a star in there. Do not ever try to clone your domain controller hot. VM generation ID and other safety features won't help you. You will get a devastated forest. What is going to happen is the clone is going to succeed and the resultant domain controller is going to pollute the entire infrastructure. Please do not hot clone your domain controller. Microsoft does not support it. We do not support it.
You heard him. All right, so then the same thing's going to happen, by the way, once you power on that new clone virtual machine. The same thing we saw in the previous scenario. It's going to generate a new VM generation ID. It's going to drop the RID pool, generate a new invocation ID, but then it's going to check for that DC clone config file. And if it's there, it's going to clone it. And one of the advantages of cloning is that if you have a large Active Directory database, it's going to start from that existing database and the contents of the sysfile directory rather than starting from scratch and replicating from another domain controller. So if you have a really big domain database, this could save some time. All right, let's see what we can.
All right, so I'm going to quickly kick off the preparation. This is going to go through and add the domain controller to the clonable domain controller and do the other preparation. These are steps you have to do for the VM, for the domain controller you want to clone. If you do not do this, the domain controller will not be clonable. If the domain controller is not in the clonable domain controller security group, you can't clone it. So we've done that, and now we are going to go into, we'll make this very manual, shut down these domain controllers. Go on.
You usually don't want to just power off a domain controller hard, but why not, right? What did I say about giving this guy rights? Okay, so I'm going to switch. Do you want me to switch back while you're doing this?
Yeah.
All right. I got a couple. We're going to come back probably a few times to this. This process takes a little bit of time. But what I want to do is talk about some considerations when you're going to actually do this. You have to shut down the reference domain controller. It can't be hot. You heard Deji say that. He really means it. You can't, and you really shouldn't try to do this with any domain controller that holds a FSMO role. Now, for some of them it will work, and some of them it won't. Like a RIDmaster, it just won't work. PDC emulator, technically it will work, but like we said before, you have to shut this thing down. You shut down a PDC emulator, you're going to have time issues in the domain, so don't do it. And obviously DNS has to be reachable. Just let me know when you want me to switch back.
It's cloning.
It's cloning. You want to see?
Yeah.
All right, so we can see the clone is kicked off. This will take a couple seconds. Again, like I said, we'll switch back a few times so you can see the process. It's super exciting. Now, let's say you want to clone a bunch, more than one at a time. You can do this. In the DC clone config file, there's options for computer name and IP address. If you leave those blank and you have functioning DHCP and you tell it how many you want, it will clone as many as you want. So if you needed to, for whatever reason, clone 10 or 15 at once, you can do that. Same rules still apply. Source server has to be down the whole time. So however long it takes you to clone 10 or 15, that production domain controller is down. So I would use this sparingly, potentially only in lab environments. The other thing you can do is you can run all of this stuff. You can populate the DC clone config file. You can do all that. Shut the virtual machine down and convert it to a template. And then provision new domain controllers from a template in vSphere, just like you would any other server. The challenge with that is at some point this tombstone value is going to expire in the domain, and then you will still be able to clone them, but they won't work. So that's sort of use that sparingly, but it is an option. And then last but not least, never perform guest customization when cloning a domain controller. Microsoft doesn't support it. It's not, the safety feature won't work, and the domain controller just it doesn't appreciate it.
Anybody here thinks they're going to be doing massive domain controller cloning anytime soon? No, we are demonstrating this just to show the capability and the feature, and the fact that it does, the VM generation ID actually does protect you if somebody were to maybe clone domain controllers. Instead of polluting your forest, your infrastructure, as in the past, VM generation ID actually provides the safety. We're still doing the cloning. It's going to take like 2 days.
Yep, so we will come back. You just watch that. So again, some reminders. Got to be vSphere 5 Update 2. Again, I expect a lot of you are already there, but just in case you're not, none of this stuff will work without that. The generation ID is only set if the server value is set to 2012 or 2016. Even if you install the OS correctly, if this value is not set right, it's not going to work. You won't get a gen ID value, and all the stuff we show you won't work. Leave that clonable domain controller's Active Directory group empty. There's no reason to leave anything in there. There's an odd scenario where you might accidentally clone a domain controller, but more likely, again, I warned you I would talk about this again, role-based access controls. Let the domain admin populate the computer object into that group, and let the vSphere admin do the cloning. Both don't need to have rights to the other systems. Where are we at, 40-something%? Okay. Validate all the software and make sure that your backup agents and your antivirus and things like that support the cloning. You're going to find out pretty soon, when you do the preparation, if it's not supported, it's just not going to work, and you're going to know it very quickly. Question?
Does your Active Directory have to be a certain
forest level? No. So it's 2012 and 26, all the way to what we have today. 2012, yes.
Right.
Yes. Now, please bear with me. We just said you can restore your domain controller, and that when it comes up, it's going to lose, it's not just its invocation ID or its USN, it's going to be a new complete entity. In a DR situation where you're replicating your domain controllers to an off-site DR, a DR site, and you have a catastrophic failure at your primary site, and you try to bring up all these domain controllers that you had waiting cold, what do you suppose will happen when you try to do that? We mentioned that they have to be able to at least get in touch with one domain controller to be able to get new seed, new read pool. What if there is no domain controller to service that request?
Clone's done, by the way.
It comes up clean? No, it does not, because there is nobody to give that domain controller a read pool. A domain controller without a read pool can't create object. You can seize a role because the domain controller hasn't even started advertising itself as a domain controller. Because it is not a domain controller. It's just a phantom object living nowhere with no line. All right, it's a little bit complicated, but it will require a multitude of reboots, okay? And there's a PowerShell that we put. I think
yeah, we have slides on that.
Yeah, we have slides on that. In interest of time, what you will do is either have, as part of your DR policy, a hot domain controller somewhere that is outside of your primary environment and is not your DR site. That way, when you lose everything here and the phantoms here are trying to come up like a zombie, there will be somebody somewhere where you can seize the role and then say, okay, please help me remediate all of these other domain controllers. Please do not forget that. Yes, VM generation ID is awesome. It's good. For DR scenario, you need special consideration.
Okay, so the clone's done.
Clone is done.
Let's pop open.
Is it done?
Yeah, so the clone completed and it's powered on, so let's look at the...
I think it faked it.
Let's look at the console and see where it is.
So we just instantiated a new DC by copying an existing DC. Usually, this is a terrible idea without VM generation ID. However, this is a happy moment because, okay, so let's go and look at.
Yeah, so what we'll do is we'll look at AD users and computers again. We'll look at the domain controller objects in here. We should only see 2, and now let's see what happens when we refresh it. Just keep refreshing it.
Is it done?
There's only 3 more minutes. Just keep refreshing it.
Is it done?
Maybe it's not done. Well, you know, why don't we go through one?
Actually, it has to reboot one.
Ah.
Yeah,
I told you it wasn't done.
Yeah.
All right, I'm going to go back. We'll come back to that and see if that is working still.
Go ahead.
Okay. Some key takeaways for Windows Server 2012 and 2016. And virtualizing domain controllers in general. I mean, I think that with 2012 and 2016, they've really eliminated a lot of the problems that historically folks had virtualizing domain controllers. It's 100% supported. VMware supports it and Microsoft supports it, all roles. No support reason not to do it. Again, multi-master, distributed, low resource utilization. These are the kind of characteristics that make an application virtualization friendly, and there's no doubt domain controllers are virtualization friendly. Now, Microsoft has a lot of documents on best practices for domain controllers, and you should follow them regardless of whether it's physical or virtual. They all apply. So it's not like you have to apply a different set of rules for virtualized domain controllers. Now, and that's true for things like time, which we talked about, security for role-based access control and things like that, DNS, which we talked about already, availability, et cetera. Active Directory is natively highly available because it's multi-master, but when you bring vSphere HA to the party, it helps domain controllers get back online faster than they could if they were physical. So you get almost better availability that way. You know, it's our opinion that if your environment supports it, and we think you should bring Windows Server 2012 and 2016 to the party for your domain controllers. The new features that are there, safety, new features in 2016 for better time sync, they're all going to improve your domain and improve your environment, especially if you're virtualized. How are we looking here?
We lived on the edge, and no, the demo broke. I apologize, but yeah.
2 out of 3.
We got, no.
3 out of 4. 3 out of 4.
No, 75%. Okay.
75% is just like my grades in school. All right.
We have a minute and some seconds are left. Can we take questions?
Yeah, well, so thank you everybody for coming. Really appreciate it. There's a mic right there if anyone has any questions, or feel free to just raise your hand. Thank you.